Good morning, everyone. Hopefully you can all see us. We'll just give it a couple of minutes and let the attendees arrive, because I know there's quite a number of you registered. So we'll just wait for a minute or so to allow people to join so no one misses anything. I can see that the numbers are gradually increasing, which is great. That's lovely. Halfway there at the moment, so there's about half the number that registered have joined in so far. So we'll just give it another minute or so and we'll get going. See if we get a few more joining. Lovely. Fab. So good morning, everyone, and welcome to NSA's online webinars. My name is Nicola Noble and I work on the policy and technical side of things here at NSA. This morning's webinar is Flock Benefits from Trees and Minerals, and it's sponsored by the Woodland Trust. So thanks again for joining us, and we hope you find this session enjoyable, useful, and are able to get a lot out of it. Just a reminder, the webinar is open to everyone, not just NSA members. I'd like to remind all non-members that NSA is a membership organisation and that we're highly dependent on our membership as a source of income for us to continue to support you and the UK sheep sector. Just a few sort of housekeeping bits and bobs. If you do have any questions throughout the session, can you please post them in the Q&A facility at the bottom of your screens? And what we're going to do is host a Q&A panel at the end of all three presentations rather than throughout. So if you could try and hold them for then. The chat function is also open for general comments, but note that if you do post a question here, it might get missed. So can you please try and use that Q&A box rather than just the general chat facility. And just a general reminder that this webinar is recorded for future viewings. Lovely. So I'll now hand over to Helen Cheshire from the Woodland Trust, who will chair the session. Over to you, Helen.
Thank you very much, Nicola, and welcome everyone from the Woodland Trust. Just very quickly, the Woodland Trust is a conservation charity which was set up in 1972 to protect, restore and create new native woodland throughout the UK. My background is actually farming. I grew up on a dairy and sheep farm in Leicestershire. So why is the Woodland Trust interested in sheep farming? Well, we believe carefully sited trees and shrubs integrated into farming systems can really help the performance of your flock and improve the resilience of your farming business, while simultaneously helping to tackle the climate change emergency and the nature crisis. And I'm very aware that the farming sector is at a critical time in its history, and there's a lot of uncertainty. So hopefully today, we believe that trees and shrubs should be part of your toolbox to help tackle some of these issues that you're facing. So we've got three excellent speakers this morning who are going to be talking about the role that trees can play within your sheep farming systems. So first of all, we have Dr. Lindsay Whistance from the Organic Research Centre. She's a senior livestock researcher and will give a general overview of trees and sheep. Then we have Dr. Nigel Kendall from University of Nottingham Vet School, who will talk about some specific research that we've all been involved in very recently. And then finally, we have Sam Hollick from Bangor University, who is just starting his PhD, looking at the shelter impacts on the performance of your flock. So he'll talk about his PhD. So over to you, Lindsay.
Thanks very much, Helen. I'm kind of hoping that. Okay, now I don't seem to be able to move my slides. Okay. Here we go. Don't know why that didn't work before. Okay, so thanks, Helen. Yeah, so I'm going to give a general overview of how trees can benefit animals and here mostly sheep in the landscape. So if we think about things other than shade and shelter at the beginning, trees can play an important role in the social behaviour of groups. They increase positive social interactions within animal groups, and they also help really quite a lot in terms of body maintenance behaviours. We tend to disregard or reduce the importance of body maintenance behaviours. But for animals, their coat and their skin are a frontline defence against disease, and they spend part of every single day maintaining their skin and their coat, removing dead coat, dead skin, removing external parasites and seeds that can penetrate the skin. And they also scratch against mites and against fly strikes, so can help give early warning signals to farmers that there is a problem here that needs addressing. In terms of trees in the landscape, they provide a great deal of buffering for different weather conditions. And we can see in the top left-hand corner, the only grass that is present in this landscape, which is the summer of 2017 in Wiltshire, is directly under the apple tree. And the farmer behind this field had to sell his livestock off early with no grass growing and no hay or silage gathered for winter feed. To the right-hand side, we have an established ash silvopasture system in Ireland on land that is very wet. And this system has enabled this farming practice to extend their grazing system by a full 17 weeks. And it's also helped with fluke problems. On the bottom left-hand corner, you can see just how a canopy, even without the leaves, can increase surface temperatures. And this can increase by up to 6 degrees, both bringing benefits to the animals, but encouraging early spring grass growth and extending the season again into autumn and winter. And of course, these higher temperatures enable animals to select a nicer environment to lie down in when they're housed outdoors in the winter. So Sam going to give you some very specific examples with sheep and temperatures. So I'm going to stick to a cattle example here that I've sort of worked out as a story. And I really want to illustrate how cold wind, cold air and rain can all affect animal welfare and productivity and really increase the burden on the landscape quite dramatically. So if we take an air temperature of around 2 degrees centigrade, and then we add a 16-mile-an-hour wind to that, a cold wind, then we're effectively reducing the air temperature to -7 degrees. Now, if we consider that a healthy beef animal with a good winter coat has a lower critical temperature of around 0 degrees, and we then put that animal into that environment where the air temperature is now -7 degrees, this animal will require now an extra 14% of feed, because for every 1 degree drop in temperature, this animal goes below its lower critical temperature, it requires an extra 2% energy. Now, if we now take this scenario when we add rain to the mix, if the coat is wet, then that animal's lower critical temperature will hike up to about 15.5 degrees. So this means that under these conditions, this animal is now 22.5 degrees below its lower critical temperature and will therefore need a 45% increase in food, in energy. And so this is a real burden, both in terms of welfare, in terms of productivity, and in terms of the burden on that landscape, which is now having to find that extra food for that animal. So perhaps one of the most critical points where cold really plays a part is the survival of lambs, particularly when they're being lambed early in the year. Now, a good 30% of lamb losses are attributed to hypothermia and starvation combined. And this is perhaps not surprising because lambs have very little body reserves. And when you think about how hard it is to keep warm with very few body reserves and with a wet body, then it's not really surprising to learn that they can lose around 10 degrees of body heat in the first half hour of life. So they're highly reliant upon their external environment and maternal care to maintain life at this stage. It's very important to understand that ewes have different needs and wants at this time. Although the lambs need shelter, the ewes don't necessarily need the same shelter, but they do need food and they do need water. And if the distance between the shelter and the food and water are too great, they will leave that shelter, bringing the lambs out into exposed areas. So the closer that food and water are to shelter, the more benefit the lambs will gain from this shelter. And it's really quite critical that they stay there for as long as they possibly can over the first few days of life, because not only do the lambs survive better at the point of being born, they also it also improves their relationship between the dam, so they have a stronger mother-offspring bond when they remain in shelter. And this also then increases their survival to weaning. So enough of bad weather, let's go to the warmer end of the year. And really, although shelter is incredibly important in the cold part of the year, on a global level, shade remains the single most important thing that trees can provide for livestock. Now, if we consider the negative effects of too much heat, so when we reach the upper critical temperatures with animals, what we have, if animals are not able to seek shelter, then they will have to change their physiology. So they redirect their blood away from internal organs, the reproductive tract and the digestive tract, and they move this blood out to the external areas of the body in an attempt to cool that blood down and to maintain core temperature. So the moving of the blood away from the reproductive tract causes fertility issues, and it causes impaired fetal growth. The removal of blood away from the reproductive tract causes permeability of that reproductive tract. So what you have, with roughly up to 50% of blood removed, the permeability of that digestive tract increases, and it allows toxins, mycotoxins, aflatoxins, to move out of the digestive tract and into the bloodstream. And this can trigger inflammation cascades. And we find that in dairy farming, you get a huge hike in mastitis in animals that are unable to seek shade. And these are really, really expensive problems for farming overall. And some records from America have shown that heat stress causes the dairy industry over $900 million on an annual basis. And the same is true for beef cattle, where it costs around about $400 million every year. And of course, all of this loss in productivity is based on poor animal welfare. So it really needs to be addressed on multiple levels. So what we find with agroforestry systems, well, solar radiation can be reduced by up to 58%, and skin temperatures can be also reduced by around 4 degrees centigrade compared to those animals that are out in exposed landscapes. And what we also find is that because of these cooler temperatures, because they can seek shade, they tend to normalize their behavior patterns. So their food intake is maintained, and they also have active resting and active rumination bouts. So productivity is also maintained. And then also we find that they utilize this landscape more evenly, so that the nutrients are more evenly dispersed in that landscape. So if we think of browse as a feed, well, we can see by this annual diet composition graph that actually all of our livestock use browse as a food source, as a natural food source. And across a year, the annual intake of browse for sheep is around 20%. But this can fluctuate. So there are times such as very attractive spring growth, or times of the year when there's very little grass growth the intake of browse can really increase quite rapidly, and for sheep this can go up to 76%. Well, it's perhaps not surprising that they are attracted to leaves, trees, as a source of food, because most of the, well, all that I know of analysis that's been done of leaf nutrition, when compared to grasses and forbs from the same environment, they compare very well indeed. So this is some work that was done in 1917, where for Swedish farmers, and I should note that the three species that have been mentioned here, they aren't necessarily related to the palatability of them, but they are simply those trees that are available or were available to those farmers at their time, and everything was utilised as much as possible. But in terms of fat, sugar and protein, largely all of these trees outweigh both the meadow hay and the red clover. The more up-to-date research that's been done on the effective degradability of nitrogen and the crude protein content indicates that trees again compare very well. So this has been compared with alfalfa and ryegrass, and it's very, very clear that whilst others compare reasonably well with these two grasses, the mulberry is outstanding, both in terms of effective degradable nitrogen and crude protein content. But one thing that the grasses don't have is condensed tannins. And what we've learned more recently is that up to 5% of dry matter as condensed tannins can have a positive effect on the diet. And it does this in reducing the amount of protein that is broken down in the rumen, and it's delivered to the abomasum, so effectively delivering high quality rumen bypass protein. Now, protein, of course, is an exceptional, a very important nutrient for growth and for health, but it can also aid animals in managing their parasite issues. And the other thing that condensed tannins does is that it reduces the amount of methane that comes off feed during the digestion. So Willow, for example, produces less than half of the methane that Lucerne does. Now, I'm not going to go too much into trace elements. I know Nigel is going to talk about this a little bit later, but just to say that really trees can offer a very good source of trace elements overall. And some of the research that's been done earlier indicates that as dried sources of nutrients, the amounts are higher. So this perhaps indicates that these could be a very good source of nutrients in areas where these are problems, or in farming systems where this is an issue. Now, I've pointed out Salix caprea is goat willow, and I've pointed out the amount of phosphorus and the amount of calcium, and it very nicely manages the 2-to-1 ratio in the fresh goat willow. And I've pointed this out for the next slide, really. So I wanted to indicate, if you see the steer with the half-dead rabbit in its mouth. This is really the moor system, where animals are not given extra feed or extra supplements. They have to go and find nutrients for themselves. So in this system, it's a poor phosphorus and a poor calcium system. And so this animal has sought out one of the better sources for these nutrients. It's quite a grotesque image, I think, but it indicates very, very clearly that animals are capable of going and looking for nutrients, and they have an understanding that finding it as a food source is a way of rectifying those imbalances. So the other things that trees can bring along with good nutrient sources is medicine. And we know, for example, that willows and poplars are very high in salicylic acid, which is the precursor to the medicine, the painkiller aspirin that we use. But salicylic acid also has anti-inflammatory properties, it has antifungal properties. And so it really is an all-round good chemical to have for animals to have access to. So there is some evidence to show that when sheep are offered poplar and willow species that have different levels of salicylic acid, they automatically and systematically go for the species with the higher levels of salicylic acid. Now, we don't know why, but what it does tell us is that they can make that distinction for themselves and they actively seek out that property. So I've mentioned parasite control with a higher protein, and there's some evidence that higher protein can also help with future resilience. But the condensed tannins also have a very important part to play here. So what we find with the condensed tannins is that they will bind to the third instar. So once the animals have ingested these larvae, the L3 larvae, they can bind to them. It stops them growing into adults, and those that do manage to become adults, they remain small, so they lay fewer eggs for the next population or the next generation, so further reducing the burden on the landscape. Additionally, some studies that have been done with sheep with high parasite burdens, when they've been offered plants with high condensed tannins, they go for those plants with a higher condensed tannins, and they can reduce their parasite burdens by up to 50%. So there are lots of benefits, and a further benefit, of course, of having browse is that you remove the animals when they're eating the browse. You're taking them out of that risk zone, that 15-centimetre risk zone down at the ground where they are likely to take on those parasite problems. So if we're talking about feeding browse to animals, well, there are a few ways of doing it. Direct browse is probably, certainly is the most natural. And so we have to consider browse height. And for sheep, this is around 1.2 metres for comfortable browsing. We can also bring it into agroforestry systems where you've got trees that are mature enough for harvesting in some way. And in the top left-hand corner, we have a farmer who produces all of his own wood for burning. And then when he goes and harvests, he drops and allows his sheep to browse the wood clean for him to then come along and harvest that again. And in the bottom right-hand corner, we have dried hay, tree hay, and this is used for dairy goats. This particular image is for dairy goats in Belgium. So palatability is, of course, an issue, and we have a lot more to learn about this, but this is something that the Woodland Grazing Toolbox created, and we find that aspen and willow are particularly high, but really down to number 5, or score 5, the birch and the hawthorn, all of these trees are browsed quite well, and certainly the hawthorn I think should be higher than it is, and they also note the same thing. But beech and alder are issues with palatability. Now, palatability is a complicated thing. It isn't just the hedonistic sense of the sugars or whatever it feels like in the mouth. It's a very sophisticated relationship, both a chemical and a mechanical relationship with feedback from ingestion. And what we find with animals that need certain components, such as the sheep that have heavy parasite burdens, and they are drawn to those plants that have the components that they need. There's a particular study done with sheep in Australia, I believe, but they were looking to see how they could maintain vitamin E levels in lambs that are born in conditions of drought. So all the grass is dry and there's very little vitamin E, predisposing these lambs to white mussel disease. So they wanted to know if they would eat the bitter shrubs that still had the green leaves. And they took some lambs and they made them deliberately deficient in vitamin E. And what they found was that these lambs very quickly moved over into a less palatable feed, higher in vitamin E, until they'd regained balance, at which point they moved back to a more attractive feed source. And the researchers believed that this was really knowledge at a cellular level, and the lambs were reacting to their deficiency long before anything could be measured. So yeah, that was really the end of my talk. And if I've skipped over anything, or if you wanted to ask more questions, then please use the question and answer button. Thank you. Oh, sorry. Yeah, now we should. Now it's Nigel to speak, if he's still around. Yes.
Yep, thank you. Yep, I'm here just waiting for, there's the screen, lovely. And I better request control. There we go. Right, so I can control this. Okay, so we're going to move on to some actual more nutritional benefits from trees and looking into those. Just a couple of notes I wanted to make really after Lindsay's rather disturbing rabbit. Where we're talking about Pica's nutritional wisdom, and also with vitamin E, they tend to be only when you've actually got into clinical signs that you will get a true sort of Pica behaviour, where the animal will show that nutritional wisdom, that something they eat makes them feel better. It's not something we would really see on a production basis. Yeah, we're not just going to be a little bit low, it's affecting our production. It's when it really hits the signs that we are getting clinical signs and we feel a bit better by eating whatever we're short of. So the vitamin E is a good example. Generally, we're not, in the UK, we're not usually too bad in grazing with vitamin E because, we have, I'm distracted by Catherine's background, which is grass, which, it's green, it's usually got plenty of vitamin E in. So just another couple little bits on that. Lindsay, some stuff on aspen. And one of the things I found out the other day was aspen is popular as well, so they're interchangeable. So what we know as popular trees are the aspen trees. And I believe Helen's been asking in chat for people to, in the audience, to introduce themselves and have a nice little community feel. So I know some of you might be just watching the presentation and not open your chat options, but I know Helen's screening to see who's here. So on to what we did with trees. So there we go. So we're going to go through some background findings, some work, talk about context and need, and then talk about what we did with the trees, whether this did work, and then look into some other questions we've got about using trees for fodder and for mineral supplementation, which is the major basis of this. So the background finding, we did some work with the Woodland Trust, with Lindsay at the ORC, Reading and Bangor, and the Game and Wildlife Conservation Trust, where we looked at the mineral content of lots of different trees. Again, we didn't pay much attention to the palatability, because remember, Lindsay's work, we're talking about the older being lower in palatability. But if we look at this cobalt, and we've got a huge effect of Willow on cobalt levels. It's that huge we've had to log the axis. So this is 10-fold higher. Okay. So there's our big cobalt front. Okay, 10 times the requirement. So these lines on the graph are the range of requirements. So in terms of cobalt, the solid line is 0.2, which is the lamb and using early lactation requirement. And the dotted line is the lower requirement, which is all the rest of the ewes. And this in the corner, we've now got the zinc appeared, and you'll see, okay, not logged, but we've got a major increase in zinc in Willow as well. So we have two of the trace elements that are potentially limited in grazing that are hugely high in Willow. So this then flags in my mind, oh, is this a potential supplement we use? And maybe a supplement that fits in with organic systems and systems where we don't want to be given inorganic supplements if we can, really don't have to. Okay, have we still got the basic nutrients? Well, we've got the ME and the CPs done on these, and you'll see, yep, we're still within requirements. We're probably not quite as high as grass in terms of ME. We probably are in terms of crude proteins, very comparable to grass. ME may be down a little bit compared to grass. But then again, if you look back to Lindsay's intakes, rarely are we having 100% intake of trees. Most of the time it's a mixed feed, so it will mix the grass and the trees. Okay, so the lines here are a 20 kilo lamb grown at 250 grams a day and a 40 kilo lamb grown at 150 grams a day to give us sort of requirement for the ME and CP, just in context of where we might be with sheep in production systems. So we have the basic nutrients. Okay, so what can we do with this high cobalt? Well, in grazing, the cobalt, so this is perennial ryegrass swards. Okay, you'll see this is a couple of year bit of research we did across 2015, 2016, across a whole load of fields on one farm. Regular samples about every month. You'll see we go down June, July, August, September. We are below the year requirements. We're well below the land requirement for a lot of it in these fields, but for cobalt. So you'll see we've got this potential effect that we can improve our situation. So this, if you think of the sheep, we are then weaning lambs June, July time and expecting them to finish off grass here. So we've got this big supplementation window across this summer period. So could we use cobalt, or could we use Willow to supplement the cobalt to fill that gap? So what we actually did, we had some lambs, some recently weaned lambs, 6 groups, initially into 6 individual pens. Later, they were into a pen, 1 pen, and the field. We had issues with sheep and electric fencing and respect. So we had those respect issues. They didn't respect the electric fencing, and we just then later kept the Willow ones in a large pen with grazing, and the rest went to the field. Previously worms, supplemented with selenium and iodine to make sure we didn't have any other things that interfere. 3 treatments to each group. So they've got Willow, 300 grams a head of fresh leaf, which is about 100% grams of dry matter, which is about 10 to 15% of their dry matter intake. And then just to give a positive control, we drenched some with a cobalt sulfate drench, which was given at 14 times the daily requirement, working on principle we're looking on 2 weeks. So we gave them the whole of their daily requirements in 1 dose at the start. And then we gave them nothing extra. So they either had Willow, drench, or nothing. Okay, we then got blood samples and weighed them at day 0 before we treated them, and at day 14 once we finished the supplementation. Predominantly looked at vitamin B12 concentrations, which are the physiological sort of, or the functional indicator of cobalt status. So cobalt concentrations, the grass ones down here. Okay, so this is in the grass and in the willow. So the willow, just confirming the willow is much higher. There's the lamb requirement. So the grass was below requirement, the willow way above requirement. Okay, we fed them. Okay, now these were fed in buckets. What I had was a very tall student who basically browsed the leaves off the trees, weighed them, put them in the bucket. So not necessarily a practical way to do it, but there's quite a lot of leaf there. So that's 1.2 kilos of willow leaf ready to feed to one of the pens of 4 sheep initially. Did they eat it? So, okay, so back to there we go, some pictures of them eat it. So you can see the lambs, heads in buckets, eating quite well. This picture's after they went into the larger pen, because we've got more than 6 sheep in that picture. And there's the graph of intake. So you'll see from the first day, a couple of days to get used to it, and then we were clearing 80 to 100% of the willow across the rest of the trial. Okay, so this was going, and all the lambs were consuming some. So yes, we were getting intake of willow. Did it work as a supplement? Well, control group. Okay, so we're at the bottom line is low, below that's deficient, and then we've got this little marginal band. So most of the sheep are in the marginal bound stroke just above, apart from the Willow group at day 14, where we have got this big increase where we're up to, you know, around the 700 to 1,000. So that's something that will, you know, may on a larger group give us a production response, a weight response. On the small numbers we have, we didn't get any weight response. So remaining things to think about. Okay, picking leaves is very labour intensive, and not everybody has got a 6 foot whatever student to go around and collect leaves and feed them to sheep. So how much willow is needed? Well, we were feeding 300 grams per day, and we got quite a large response. We might be able to feed less, might be able to feed it less often. Do we just cut and feed the branches, as Lindsay showed in her presentation? We've always got the willow hair, though at the time we need it is that summer where we will have green leaf. You know, or do we have a paddock that we or a wood we can just open the gate, let them into once or twice a time? So it's all these times we can think about. Are we working with energy biomass production? You know, there's all this willow being grown for energy biomass. Can we use the leaves from that? Can we plant? Can we harvest in situ? So there's lots of things to think about in terms of the practicalities of this. Are we planting hedgerows, windbreaks? Sam will probably talk more about wind later on. And then, of course, the other bit are the anthelmintic properties. Now, we did monitor in a recent trial the fecal egg counts were in feeding some willow in a later trial, and that trial's still ongoing. But theoretically, we've got the tannins can cause an effect on worm burdens by monitoring the proteins, and there's supposedly some direct effects on particularly, I think, the larvae. And also things like the cobalt status itself and even the zinc status have immunology or immuno sort of type effects on worms. So if you've got cobalt deficiency, you're more likely to have worms with your status, with this change in status. So there is a potential of worms. At the moment, we haven't fully looked into analysing that trial, but we have measured it. So that's something we'll be looking at in the future. Okay, so that's just going to be the end of my bit for now. We'll come back to the panel, but the Woodland Trust funding this work. Ben was the project student and Giraffe, very useful for getting into the trees. Christo to the Allerton Project, who we work with closely on that aspect of the work. And then, of course, the earlier work was the Bangor ORC and Reading links working on the background work. And Nivetna, which is an analytical service that we run out the School of Veterinary Medicine, especially in the trace element and mineral analysis, which also topped up some of the funding as well. Thank you.
Okay, I think I'm up next. Here we are, there's my slides. Yeah, so my name's Sam Hollick. I'm just started my PhD at Bangor, working with Woodland Trust as part of the KES2 East programme, which we have funding for here in Wales. So yeah, I'm going to talk quickly about my my PhD research, looking at some of the kind of trying to get into some of the detail of the numbers of the shelter benefit. So next slide, please. Great. So these, for my work, these are the kind of 3 areas I'm thinking about and where shelter can provide benefit. So through reducing mortality, you know, cold and heat exposure, bad for animal health. Through season extension, if we're talking about changing the microclimate near trees, then does that allow grazing to carry on longer and so reduce costs from housing and extra feed. And what I'm going to focus on today is feed conversion efficiency. It's the idea if we can spend less energy on maintaining body temperature, can we have more energy available for growth? Okay, next slide, please. So this is a very simple model, but the kind of simple overview we can have for looking at energy in sheep is we've got energy coming in from feed, labelled A in this diagram, and then we have energy lost to the environment, labelled B, and energy lost in manures. And the difference there that gives us the balance with energy, then that's what's available for growth. So if we take A minus B plus C, that gives us how much energy is for growth. That has to be used for things like wool growth, milk production, developing the prenatal lamb. But that is essentially the envelope we're working with. So the principle is, if we change B, if we can change this energy loss to the environment, can we improve that B conversion efficiency if we're providing more energy available for growth? Okay, next slide, please. So we can look at how this energy balance changes, the energy requirement through B changes with the environment. So these two graphs we've got here come from an earlier Bangor University study, and we have these coloured regions that show the kind of thermal conditions. So in the middle we have the zone of thermal comfort. Here the B is balanced, this energy lost is balanced by the energy produced just by staying alive to kind of tick over metabolism. And as we get further out, the kind of light blue and yellow is where behaviour changes are necessary to start to maintain body temperature. And then out into the red and dark blue, extra energy is spent on maintaining that body temperature. So in the dark blue there, you can see that lower white line labelled heat production increasing as we go to lower temperatures. If we add in the effect of wind, the graph below, you can see as you go up the graph to higher wind speeds, all these coloured regions shift to the right, they shift to higher ambient temperatures. So how we can think of this graph is if we're somewhere in the middle, some sort of kind of mid wind speed and mid temperature, say in the dark blue region. If we add shelter in, we can reduce those wind speeds to the same temperature and move down the graph back into the light blue and hopefully the green region. So we're reducing the thermal discomfort and therefore providing reduction in the energy requirement. Obviously, if we're looking at the hot ends, it'd be a different picture because we're then providing shade. So that's going to reduce the energy coming in from sunlight. So it's a slightly different picture there. So next slide, please. So yes, just to kind of get an idea of how significant this energy loss is, just kind of put some numbers up here for a couple of examples. So this example, I thought would take post shearing. So I'm thinking about what are the points in the kind of sheep production cycle where kind of this could be important. So looking at post shearing, taking data from the AHDB for ewe nutrition and data for the kind of the lower critical temperatures that Lindsay was talking about earlier, that have been kind of derived from studying individual animals. We can, look at the weather conditions in the first week of May at the Bangor University farm, some of the historic data there, and we can take typical temperatures and typical wind speeds. Now, without wind, we can see that 31% of daily intake energy would be required to keep warm. This is post shearing, so that's why it's relatively high. And if we add in the effect of wind, so we can calculate theoretically a wind chill temperature from that, that goes up to 41% of daily intake energy. So we're seeing about a 10% difference in the energy requirement in this situation. So we'll go to the next example. So next slide, please. So the second example, I thought I'd go to the middle of winter. So we're looking, now the sheep have full fleece, so it's a 10 centimetre fleece, and they're in late pregnancy, the ewes. And if we look at typical weather conditions here, without wind, it comes out that no extra energy is required because the fleece is providing enough insulation. If we add in the extreme wind speed of 12 meters per second, which was seen only in one of the kind of last 5 years of the data that was there, I should say this is a lowland site, so obviously more exposed sites might see this more frequently, but at the 12 meters per second wind speed, we jump up to 11% of daily intake needed. So that kind of, again, is about a 10% difference, and that's got obviously a crucial stage in land development in late pregnancy. These figures, just to kind of talk about these examples, these are all obviously done from what data is available, and this weather data is daily averages. So with my work, I'm hoping to kind of get more into the detail of the variation over the course of the day. So if we go to the next slide, please. Here's just a little summary of the work I'm going to be doing, my kind of first bit of experimental work. We've got these electric model sheep that you can see in the picture here. It's got real sheep's fleece on the outside, but on the inside, it's got electronics, and it's powered by a car battery. And so we can statically maintain the body temperature through the electronic circuits inside. And this will basically give me an odd-shaped thermometer. I can put that sheep out along with sensors to detect wind speed, ambient temperature, rainfall, and incoming radiation, and say, okay, well, what energy is required to keep warm, and that gives us the effective temperature that the sheep is experiencing in those environmental conditions. So once I've calibrated that thermometer, so seeing how that temperature varies with adding in different wind speeds and radiation and rainfall, we'll then be able to go and put these sheep out on the farms next to trees or far from trees and exposed sites, and see and get an idea in practice about what the energy loss the environment is in real farming systems, and therefore kind of trying to put a bit of a number on the kind of benefits in terms of feed saved or kind of growth benefits from maintaining from losing less energy to the environment. Okay, I think that's my last slide. So we just move through. Yes, so thank you to my funding partners, and yeah, please put any questions and answers in the Q&A box, and any discussion in the chat. I'd be interested to hear any general thoughts about my work as well. Okay, thank you.
Thank you very much to all three of the speakers. I'm conscious that it's 12:45, not 1, as I incorrectly said in the chat. But hopefully we're all here till at least 1 o'clock. So hopefully you as attendees can be. So we'll start. Look, I've got some questions in the Q&A. So if you have any more, please do pop them in. So just quickly looking at them. Well, I think the first question came in right at the beginning, which was when Lindsay was talking and was giving an example of the cattle. But hopefully we've possibly answered now that with some of the additional information and obviously Sam's talk. But basically that was asking, what about sheep? What about the core temperature and extra feeding? So, as we've heard from Sam, this is very much what his work is going to be all about. So Marie has said, we are obsessed with fencing off trees, planting hedgerows with limited species funded through schemes such as HLS. Could a more regenerative and holistic approach be encouraged by countryside stewardship or future schemes, e.g. planting willows to be grazed and for shelter belts for tree hay? So who would like to answer that first? Nigel?
Yeah, just coming in, and it also, if you almost link into the next question, and almost linked as well. Yeah. On that. So yes, we have got the hedgerows around. Yes, we can use those. There's trees in them. If they can't reach the trees, we can drop branches. It also links to a couple of the questions or a couple of the comments that come up in the descriptions people have had in general chat. We had one where somebody's got trees in the scheme and can't graze them. Does that still mean that they can actually prune those trees and drop some of the branches into the field to utilise the fodder, and also sort of still work on improving their tree shape or when they come to carry out thinning things? So there's still ways to work around this. We're just got to be a bit imaginative in my mind. Yeah, so that was and there are people there with them using, so it's almost a bit of a two-way here. I think it'd be good to get some interest on how people are able to use their trees, because there's ways as well. And then the other thing, as well as the hedges, and coming to the other question, yes, we can plant rows of trees, we can do little blocks of trees. I think there's people, put a little block of trees in the middle or make a little windbreak. There's lots of different ways that this can be done, and it is sort of almost farms or enterprise specific. How is the best way for you? Is it better to have rows of trees 40 meters apart, the old sort of agroforestry systems, where we can go down with a sprayer boom, or are we wanting the wind to be screened off from a certain side, so we're planting a windbreak which we can equally graze? So it's been inventive and working systems that work for us. Do we want to, when we're walking around checking the sheep, we just walk around with a pair of lopping shears or things, and we can drop down a branch occasionally. And it may be thinking at a time. We drop down a bit of willow when we've got growing lambs in the field. Otherwise, we might use another species.
Okay, thanks, Nigel. Sam or Lindsay, do you want to respond to any of those? Quite a few points in amongst all that, but anything specific to add?
Yeah, yeah. Oh, sorry, Sam, you go ahead.
Okay, thank you. Yeah, I mean, I think this is the kind of the second linked question more so, but I think on the idea of planting where to plant trees, I think a mixture of systems on a farm could be useful. So at the university farm, we have a silver pasture experiment, and obviously that commits, a long term to have trees spaced out in the field, to have them like that. But it could definitely provide, those useful benefits at parts of the year. So like that Irish example in Lindsay's slides, it showed they had season extension. So you may well want it just for those, 1 or 2 fields that allow that. But obviously hedgerows can go across a whole farm and can provide that general shelter. And shelter belts can be placed at the right place to provide general shelter across the farm, because they're taller, they provide shelter for a larger area.
Thanks, Sam. Lindsay?
Yeah, I mean, I would agree with all of those things. And also, it is quite frustrating that that we've really separated trees from the agricultural environment, or the pasture environment. So we're having to relearn a lot of these skills, and finding where we can incorporate trees and use them to everybody's advantage, including the livestock. I think I'm working with some farmers in a field lab currently who, down in Devon, we've got 8 farmers that are re-establishing silvo pasture. And what we're finding is, whilst they're happy to take part, it's really quite a shock when they realise how much land is then removed from the pasture system, and certainly during those first few years when the trees have to be protected. So there has to be some sort of acceptance of a shifting landscape in some way, but the overall benefits outweigh the loss of pasture. Certainly they outweigh the loss of pasture, both in terms of productivity and in terms of the increased benefits to animal welfare. And I would say, thinking about trees in different situations. So if we're planting trees, putting them in so that they perform what they need to perform in that landscape. So if we're looking at shade and shelter, then that will potentially be different to browse trees. It may not be. It may be that they can all function in the same way, but it may be that if we're, for example, looking at willow in particular, it may be worth looking at something like Tim Downs has done, and planting specific willow, if you like, browse bars. They're not hedgerows, they're more like browse bars, where the animals can move past them in some way and spend some time browsing before they then go on into another field. So you're managing access and you're managing damage in one go.
Okay, thanks. I'm just conscious of time, and there are quite a few other specific questions. So if we do these with quick answers, and then we can perhaps have a little bit of a discussion about what the future support schemes might do to help some of these issues we've highlighted. So Carolyn says, is there any ongoing research to discover if the increase in cobalt due to feeding willow results in weight gains in lambs?
That's probably me, isn't it? It's one of those things that to get a weight effect, you need 100+ lambs per group on the willow. To get a blood response, we can do that with half a dozen to a dozen lambs. What you can do is extrapolate that up. If you are getting from a deficient area, from a deficient to an adequate, you should get a response. If you're going from a low adequate to a higher adequate, you're unlikely to get the production response. So it's the level of the deficiency, really, or the level of the problem you've got. If you've got a problem that's affecting your production, then willow should bring you out of it. Okay, so in terms of the results, doing it on a large scale, no, but it also links into, be quite interesting to see some of the people who have started sort of using trees, particularly willow feeding. There's one in the chat that certainly was talking about that, and following up to see how we're affecting the status of those animals. Ideally somewhere where there's some animals that don't have the access but are grazing another part of that pasture or something, so we can start seeing whether we are really getting the effects and how much use this can be.
Okay, thanks, Nigel. Maybe something to think, maybe how we can work with NSA and their members to look at doing some gathering some of that practical, perhaps more anecdotal data that can feed in. So Liz has asked, what is in ivy that sheep go mad over? So Lindsay, perhaps that's one for you.
No, it's not.
No?
No, I don't know.
Does anybody know why sheep go mad in ivy?
Well, we know that they do go mad, but there's conflicting evidence. You know, some go mad and then some don't do well on it at all, and there's too much to know about it. I'm very cautious in. I mean, I absolutely recognise that it can be a very good feed source, or at least it's a highly attractive source. But we need to do more analysis on it, and so far that's not been done. And okay. I know we certainly talked about incorporating it in our analysis, but we didn't get that far, did we?
No, so something for us to think about going forward. I think there's lots of unanswered questions at the moment in this. And then Jan Ledoux said, any comments about the differences likely to occur between wool shedding and wool sheep in terms of heat cold stress and so benefits from shelter? Anybody would like to have a go at that? So this is asking the difference between the breeds that shed their wool and normal sheep that need to be clipped.
I don't know if this is answering the question, but it's made me think about some work that was done with sheep in Mediterranean conditions with very little grass. So they're on drought pastures that had access to browse, and they had better wool quality, a better wool staple, which of course, you know, that indicates that the animal is healthier all round. Now, I don't know if that really is a difference, but at least it indicates that the sheep going into winter will be able to maintain its health and welfare in a better way.
Okay, yeah.
Sam, is that something you can potentially look into using electric sheep, like by varying the amount of fleece you put on the sheep and seeing the extremes it's exposed to?
Yeah, for sure. I mean, that's one of the ways I like to extend it, is looking at different lengths of fleece on the model. So, you know, I could then, because it might be that actually, you know, with the right level of shelter, that, you know, shorter fleece is okay in some locations. You know, obviously it will depend upon what your kind of your kind of ambient weather conditions are. You know, if you're in a very exposed site, then you're probably not going to be considering these breeds anyway, I suppose.
Okay, thank you. We've got a couple of more questions, so I'm just conscious that we get them asked. Oh no, yeah, true. If we have, so Heidi has asked, we have willow and aspen growing in the garden. If we push twigs into the ground now, will they root in our hedge line? So does anybody on the panelists fancy that? If not, I might ask my colleague, Kath.
Yes, they will. But yeah, I mean, Kath can by all means answer it, but yeah.
Yeah, certainly I know that willow is very effective at doing that, isn't it? But so yeah, let's go for it. Go and have a go. And then Scott has asked I think this is an excellent question to finish off actually with. If I was to go out today and buy one species of tree to improve my flock, which would it be? So how about all three of you panelists have a go at answering that in turn? So Nigel has unmuted himself first.
My thoughts coming from minimal supplementation would be willow. It's got that tenfold cobalt, the slightly higher zinc, and those two will be useful for you know, they're ones that will work with your grazing, with your grass, to hopefully prevent deficiencies and improve production. So that's totally coming from that area. Also, willow seems to be, as we said, easy to grow and fairly rapid to grow, and also has the other biomass sort of uses and coppicing uses as well. So that's my answer.
Okay, thank you, Nigel. Who'd like to go next? Lindsay?
Yeah, well, I would also, if you force me to choose one, I would also have to say willow, but please don't reduce it to one species. Think about mixes, think about other benefits. If we think about hazel, for example, there's been records of good levels of copper in hazel, which can be really valuable, particularly where there are problems with homuncus. So yeah, don't reduce it to one.
I know, and from a conservation point of view, diversity in species is absolutely critical. So in terms of preventing impacts of tree diseases, etc. Sam, over to you finally.
Yeah, I suppose I'm more interested in the kind of the structural things than shape of the trees than anything else. So I'd pick a good hedgerow species. Again, a mix is better, but something like hawthorn obviously is, you know, used widely for hedges because it has that nice open structure that allows some filtering of wind. You know, you don't want to choose a species like one kind of cypresses like you get in garden hedges, because that's very dense and that won't provide you the kind of shelter over the longer distance on the farm side, kind of scale of the farm field.
Brilliant. Thank you very much. I think we haven't got any new questions in the Q&A, and as it is 12 o'clock, I think we perhaps better start drawing it to an end. So first of all, I'd like to thank very much all three speakers for their excellent presentations, and for NSA organising this webinar, and very importantly for all of you joining us here today. The Woodland Trust does have an exhibition area on the NSA webinar, so please go and visit it. There's a short film of some sheep farmers up in Cumbria talking about how they've implemented trees, and lots of information about how the Woodland Trust can support. So those of you who are interested in tree planting, do get in touch. We have advice and very heavily subsidised tree planting schemes to help support you. And I think from my point of view, just one final point as chair is that actually we are working very hard with lots of other organisations and DEFRA to try and make sure, and in the devolved countries, to try and make sure that future environmental land management schemes don't see trees as ineligible features, don't stop you from grazing them at the right time, and encouraging farmers to integrate them into their farming systems. We're going to be involved in a DEFRA test and trial on agroforestry with ORC and the Soil Association and Abacus Agriculture to help really look to see how elm in particular can be designed. And our colleagues in Wales are working extensively with the Welsh Government on an edges and hedges scheme. So really do get in touch with us. We'd love to hear your feedback on what you want from these schemes in terms of trees, and things like natural regeneration. We'll be really pushing for that along with planting. So we really would like to hear what you've got to say, because it's got to work in the practical farm situation. So over to you, Nicola.
Great. Yeah, just reiterating what Helen said, really. Thank you, everyone, for attending the webinar. Big thank you to all our speakers and for the Woodland Trust for sponsoring the event. And we hope you've all enjoyed the session and you've got many take-home messages. Once again, thanks to all our members for your continued support. And again, all our non-members that have been watching, if you've enjoyed today and like to see a bit more about what NSA does, you can go onto our website and see all the benefits of joining National Sheep Association. So yeah, hope you'll have a lovely day, and tune into some of our webinars a bit later on. Thanks very much, everybody.
Thanks, everyone.
Have a lovely day.
Bye.